Okay, this is study guide 4, question number 2. We're going to define a relation P on the integers as follows. For all m and n in the integers, m is related to n through p if and only if m and n have a common prime factor. So I'm just going to start by saying what that means to me. I'm going to say that I'm just going to write sort of p divides m and p divides n. That's sort of what that means. They have a common prime factor. When I say factor, I can sort of say that it divides that. So another way of saying this is m is equal to pk and n is equal to pl. Okay? I don't think I'll need to use this for this problem. But if we were being asked to prove something, this would be the way I would start defining things. So the first question is whether 15 relates to 25 through p. So how I'm going to solve this is I'm going to find the prime factorization for both numbers. I'm going to start with 15, and that's 3 times 5. Those are both prime factors, so we're done. 25 is 5 times 5, we're done. Those are both prime factors. And you notice that we have a prime factor, 5 is prime, and they share a prime. So this statement is true. 15 is related to 25 through p. Okay. Our next question is 22. Related to 27 through p. So I'm going to do the same thing. I'm going to find the prime factorization of 22. That's 2 times 11. Those are both prime, so I'm done. And then 27 is 3 times 9. And then 9 is 3 times 3. Right? So we notice that we only have our numbers here are 2 and 11 on this side, 3, 3, and 3 on this side. There's no prime factors that share. So 22 does not relate to 27 through p. Okay. Next question is 3 related to 5 through p. Well, 3 and 5 are both factored completely. And there's no shared prime factor. So 3 does not relate to 5 through p. And finally, is 8 related to 8 through p? I know it is because they're both the same number, but we can still find the prime factorization if you want. 8 is 2 times 4. And 4 is 2 times 2. And again, it's the same number. So they both share 2 as a common prime factor. So 8 relates to 8 through p. And that's the end of question number 2.